Okay, so welcome everybody. Today we will be looking at IMDb part 3. Okay, so from databases to the web. So what's the plan? So this is originally announced 2-week lecture structure. So we were looking at this IMDb application. However, we were focusing solely on the data management aspects. And today we will be looking a little bit at the security and web development issues behind that. Yeah? So I'll show you slides, and we'll show you a concrete project, not Jupyter, but Python, and then you will see what that means. So basically I showed you these kind of slides. Yeah? So we look at the IMDb webpage, and that's pretty cool. You can look up information for all of these movies, yeah, and you can search for movies, for instance, Django Unchained. If you haven't seen that movie, take a look. Yeah, and then you get all kinds of information about that movie, who was playing, the actors and the director, of course, and so forth and so forth. However, yeah, that's a nice web page, but we didn't look at how to get the data from the database out and use that data to generate such a web page in the first place. So we were only looking down, yeah, from the database. Okay, how is it organized? Relational model, SQL, relational algebra, blah, blah, blah. But we didn't look at all on, okay, now I have the data in the database, but how do I create such a web page displaying the data? And that's what we will be looking at today. And to give you some overview on how that works, so basically these systems are all organized in layers. So we looked so far at the database system layer, and we saw certain instances, examples for that. We played with DuckDB a lot. I mentioned also PostgreSQL, and there are many, many other databases I mentioned. And of course, underneath the database system, there's the operating and the file system. So whatever you do in the database system, at the end of the day, the database system will store files to the file system. Yeah, it will map the data in those relational tables to files in the file system. But the idea is that you do not write those files yourself anymore, but the database system will take over and will handle all of the magic and save you a lot of work. Yeah? And of course, the operating system and the file system run on some hardware. And in this layered architecture, the idea is really that you don't bypass the layers. Yeah? So the application that you develop in whatever language of your choice, be it Python, Rust, JavaScript, PHP, you name it, yeah, this huge block you develop on top, maybe using a database system, is just another layer. So you have one big application sitting on top of the database system, and that application could be layered inside, but doesn't have to be. Yeah, so even though I'm displaying 4 layers here, yeah, inside those layers, you may have nested layers. In particular for database system, if you attend the core lecture database systems, eventually you will see that, oh, there are so many layers inside that database system layer. So it's a general thing you do in software design and software architecture, that you structure your systems into layers. And yeah, actually, when you do that, you quickly get the idea, hey, I mean, I can break up my application into way more layers, and that makes a lot of sense because I save work and the concerns are separated. So one standard thing you do is typically you split it up into a UI that displays the stuff. Huh? That's the part of the software the user works with, yeah, like a web browser, for instance, and stuff being displayed in your web browser, versus the actual application. So application doing computations, querying the database, taking the data, and doing something with the data. Yeah? So that's one way of splitting that up, but you could split it up even more, and that is something we will be looking at today, because if I go back to the previous slide, so once you start developing an application, and then you fiddle around with SQL statements in your application. That's basically what we did in the Jupyter notebooks. There we had this Python statements, and then we sent SQL statements, and we got relational data back. And you feel like that's pretty nasty when you develop a bigger application. So there's a so-called impedance mismatch between the object-oriented world you're typically programming in and the relational world from the 70s, yeah, with flat relational tables. And at this point, when you get data from the database system, or you send data to the database system to insert stuff, for instance, yeah, you have to convert like tuples into objects and objects into tuples and so forth. And that's called the impedance mismatch. Yeah. And to fix that, people came up with the idea to have another layer. Yeah, so have another layer in between application and database system, and that's called an object relational mapper. So the idea is the application will talk to that mapper, and the mapper will then in turn send all the SQL statements to the database systems. You don't have to send any SQL statements here. You will do something different from the point of view application. We will be looking at an example of this today. Well, but of course there's more layers. So one is that you could introduce what's called a back-end framework. So a framework allowing you to more easily develop web applications. One example of that is Django, and I will introduce Django in today's lecture. That's here. And you could do even more. You could split up the UI application from the back-end application. You see it here. So that also then allows you to use different languages, different technologies for these two layers. But it also means that typically this stuff is run on the client's computer, so on your browser, on your smartphone, on your laptop, and this stuff here is run on a server, or even multiple servers, if you want. Yeah? So all of this, eventually all of these layers have to be mapped to certain servers, to hardware, and the more layers you have, the more degrees of freedom you have to map those layers to servers. Yeah? So this is how an architecture could look like. Don't worry, in reality, it's way more complex. Yeah? So in particular, if you ever looked at modern software development using services like Amazon Web Services, for instance, it's crazy. Yeah? You have all kinds of orchestration, you have containerization using Docker and then Kubernetes and whatnot. It gets more complex. And there are ongoing discussions whether it has to be as complex like that. But conceptually, this is all you need. Yeah? This is basically a good architecture. And I will be showing you an example project that's based on the IMDb data we're using in this lecture. And maybe just to give you an idea on how this looks like, let's switch to that project. So basically that's now using this Django I will explain in a moment. And yeah, it's a web page that allows you to browse certain movies. That's exactly those movies from the three directors we used in the previous lectures in this course. So basically you can browse those movies that are available. You can also look into details. So when clicking on a link here, you get information about the actors that played in that movie. Of course, you can make that nicer using all kinds of CSS magic and JavaScript and whatnot. Yeah, but that's not the purpose of this lecture. There will be a dedicated web development lecture. My focus will really be the interaction of the web framework with the database and what you should know about that. Yeah? So there are other courses focusing more on making this nicer. It's more the interaction here. Yeah? So in principle, the web page is showing all this stuff. You can also compute statistics, like how many movies did you have per year, and so forth and so forth. Yeah? So that's basically, you can also search, and you can show that briefly. Yeah? If you have to, in this sample application, you have to exactly have to specify the string, even with capital letters, exactly as in the database. And then you get details about that specific movie, Aliens, for instance, and when it was produced, the rating, blah, 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 and so forth. Yeah? So that's basically the web application. It's also available on our GitHub page for you to play with. Okay, but before looking at that in more detail, let's look at the basics. So one thing I mentioned on this layout slides is an ORM. That's called an object relational mapper. And there are many examples for that. SQL Alchemy, for instance, is another one, but I will be using Django ORM. The main idea here is to shield the application developer from the database. It allows the application developer to define an object-oriented schema rather than a relational schema as we did in this lecture. You query for objects in this schema rather than for tuples, like in SQL. And you insert, update, and delete those objects rather than tuples. Yeah? So the advantages are it's much easier to develop from the point of view of the application development. You don't have to mess around with SQL. Yeah? So you see the queries and the statements to retrieve data and to save data will get much easier. And you have something that's called protection against so-called SQL injection attacks. SQL injection is that's a security attack to a database That happens the most often. Yeah? So often when you see news messages somewhere out there, hey, some data was leaked, or hackers got access to the database XYZ, in most of the cases it's SQL injection. And that's something I will explain later on today, why that is a problem and why you should really be careful with that one. Yeah? So there are many more attacks you can play on a database, but that's the most widely and the most problematic and easy. It's so easy to get this wrong. Yeah? And the interesting thing about using an ORM is once you use the ORM, you don't have to worry about that anymore. You get protection against SQL injection for free. And that's a very cool thing. So maybe you remember this slide. Yeah? So when we talked about IMDb in part 2, on slide 44, I said something like this. Unfortunately, expressions in relational algebra are sometimes a bit hard to read. Therefore, another option is to hide relational algebra expression under another language. Blah, blah, blah. Design another query language on top. Yeah? So we took relational algebra and put SQL on top. Yeah, that's basically what we did. And then I mentioned this fundamental theorem of software engineering. Well, yeah, now we can reuse that slide, of course. Unfortunately, expressions in SQL are sometimes a bit hard to read. And therefore, another option is to hide SQL under another language, and so forth, and so forth, and so forth. Yeah? So what we will be doing is there's already one layer, relational algebra. That's one API. We put SQL on top, translating SQL into relational algebra internally inside the database system. We learned about that in query optimization. And now we have another layer on top. And that's what this ORM is doing. Yeah? So, and yet another indirection. And this query language we're putting on top is called query sets. Yeah? That's a language we will be looking at in a moment. But first, in order to be able to work with Django, we have to define a schema. Yeah? And basically, the schema in Django is like the standard relational schemas we looked at, just rotated by 90 degrees in a way. Yeah? So if this is how you define a schema in the relational model, that's basically a model we had in this lecture, this is how you would define it in Django ORM. Yeah? So basically for each attribute name, you say, okay, that's the attribute name, and that equals to models dot, then comes the type, and then some details. That's it. Yeah? So you have, for instance, for year, here you just say, oh, that's an integer field, just like here, right? For rank, that's a float field, just like here, and so forth, and so forth. So basically a schema in an object-oriented schema in Django is a set of models. Yeah? In the relational world, in the relational model, I mean, it's a set of relations or relation schema definitions, if you want. So it's very similar to the relational world. Right, so these files are, those models are defined in the file models.py in the Django project. You will see that in a moment in our example project. Then what other concepts do we have to be aware of? So here you see I'm defining an artificial key, so this ID, it's of type int, that's not here. Yeah, you don't see it specified here. And the convention is if you don't specify a key in a Django model, Django will implicitly create an ID attribute that is a key. Yeah, so actually this model here has an extra field ID, which is a key. And actually when you inspect the database, I'm doing that here, movies here, that's basically what you're seeing here. That is relations, the tables being created by Django. And I'm using a tool called DataGrip. I can highly recommend that tool. It's super useful also for understanding how this object-oriented model gets mapped to the relational world. You can use it for free. It's pretty cool. There's a link in the slides. So you see, oh, here, there's another attribute. That's a key. That's where you have this key symbol here. And that wasn't mentioned in the model I just showed you here. Yeah. And then if you wonder, okay, but there's even yet another attribute here, right? There's genre, that's not there, that's not present in the database table. You go back here, so there's no genre, okay? No genre attribute, but here it mentions the genre. Why is there a genre attribute there, but not in the relational table underneath? So it says many-to-many field. Many-to-many in the relational world means an M-to-M relationship. Yeah, so I would expect that maybe Django could add an attribute called genre to the movies table, but it does not do that. Why? How did we model? Yeah?
Because it's inefficient?
No, that's not the reason. How did we represent end-to-end relationships? Yeah?
We have an extra relation that contains the IDs.
Yes.
They're related to each other.
Right. Yeah, so we have this intermediate table in the middle between, in this case, movies and genre relation, and there's a table in the middle, an intermediate table that's also mentioned in the box there. And that table has a foreign key to movies and a foreign key to genre. And that's how that information is represented, even though it's displayed here as an attribute. Yeah? So that's another feature you have here in Django. You can directly write down the many-to-many relationship without manually specifying this intermediate table. You don't have to specify that. So that's a feature of Django if you want. Yeah? So you don't have to do. You only have to do this, and now there's an end-to-end relationship all of a sudden. Yeah? These tables are also called through tables. Here's the name, through table. That's a terminology used by Django. If you want to add an additional attribute, you can do something like this. So here we had that example when we talked about Peter Sellers. So what if an actor has multiple roles within the same movie? Yeah? So you need to have a role attribute in such a through table. Then you can specify the through table like this. You say, hey, yeah, I want to specify it manually, Django. I want to have a definition of that intermediate table myself, and then you do something like that. Then you write it down like this. You see the foreign keys are present here, foreign key to actor, foreign key to movie. In addition to that, you have the role. Okay, that's how you do what we did already in IMDb part 1 or 2. I think it was part 1 where we did that. Yeah, so here you have this end-to-end relationship table, the intermediate table with an additional attribute. And that corresponds, unfortunately, to this model. Yeah, that is how Django does that. So again, as there's no key specified here, yeah, at no point do you see if there was I think I have an example later on for that. Here, yeah, so a key is specified like this. You say primary key equals true, then this abbreviation in this case becomes the grade. But here there's no such definition. Here there's no primary key being specified. Okay, that means Django will create an attribute ID, yeah, not displayed in the model, but it will be present in the database table. Yeah, and that will be the primary key. So if you go back to play in, here, that's the relational table, you see, there's an ID, there's role, there's actor ID, there's movie ID. Yeah? So that's different from what we had in the relational model. When we translated that to a relational model using entity relationship modeling, there was no ID. Not necessary. ID doesn't make sense here because the key of this relation should be all of the 3 attributes, role, actor ID, and movie ID. That's the key. Everything is fine. Yeah? But here we have this extra key column introduced by Django. So that's the difference. You have to be careful. Right, yeah? Yeah, here it's also depicted again here. So that's what we had originally when talking about that before. Okay, so keys. So that's what I said. Yeah, if you do not specify key attribute, Django will create a key attribute ID. However, we can label any attribute as primary key, as done here. However, it only has to be a single attribute. That's a deficiency of Django actually. In the standard relational model, you can pick a set of attributes to be the key. Yeah, here, this is not possible. You have to say that's a single attribute, and that's not so good, but that's how they decided to do that. I think the reason is that some database systems have problems with composed keys, and then they did it like that. Yeah. Okay, whatever. Here's an example. Yeah, so we have one attribute in this model, grades, yeah, and then this attribute abbreviation is a primary key. Yeah, so then no ID attribute will be introduced. One useful thing is there's this PK notation for primary key. So if you program something with that model and you don't remember what was the primary key, you can simply say .pk. That's automatically created and then will refer to the primary key defined for that model. So that will map, that's equivalent to writing grade.abbreviation in this case, because that is the primary key. You will see that often in Django. Yeah, as a workaround, what you should do is to define a unique. So unique you can also define as a constraint in a relational model, but here it's really important to get around the deficiency of this not having composed keys. So basically here you say, okay, yes, I have the key of that model is ID. However, I want to make sure that these three attributes, whatever combination of attribute values I receive, that it has to be unique. And you specify it in this inner class meta. There you can say, no, okay, that's an additional constraint I have. And like that you make sure that you don't get these duplicate entries, which would ruin the consistency of your data. Okay. Yeah, and then the interesting question is, okay, now how you work with Django is you define your classes, your models, and then still, okay, how do you get to the database? And that's pretty neat, because Django will do all of that for you. And these different object relational mappers have different ways of doing that, but the idea, of course, is that you don't have to do it in two different places. Both define classes and fiddle with the database schema. This is done automatically. You maintain your schema in one place, your object-oriented schema in this situation, and that means that the database schema is actually managed by Django. Django will do the job for you. So now if you change a model, so maybe go back to the, so here's a project, so here's a models file, and here you have a display of the different models being defined. So if I changed something in any of those models, like I add an attribute, I change the type of an attribute, or I rename the attribute, I mean, you have to apply the same change in the database as well, obviously. So how do you do that? And what you do is you basically call this command. Let's say manage.py make migrations. That will analyze your changes and create files that reflect the changes. Those files are called migrations. The migrations, if you go back here, basically in the project, we see there's a directory migrations. And here you have all the migrations I ever computed for this project. And each of those migrations reflects a change to the database schema. This is all automatically done by Django. You actually never have to look at that. That's not true. Sometimes there are weird situations where you have to look at that. That's another story, but the idea is you don't have to look at that stuff. Okay, so with this command, I will compute these migrations. Then still those migrations have to be applied to the database system. In other words, the database schema really has to be changed to reflect what you did in the object-oriented schema. And this is triggered by this command. You say manage.py migrate. So that command will see whether there's a migration file that wasn't applied yet to your database schema. If that is the case, it will apply that. And that even works for databases that contain data. So ideally, you don't have to do anything here. These things can go wrong, actually. So I'm in one project, a bigger project I'm working with. There are issues sometimes, but the idea is something like that, and it makes your life really easier. You can also run your project in an unmanaged mode. So here you say, well, I really want to maintain it myself. I don't trust Django. I want to do it myself. And that can be done by, again, setting this parameter managed to false. So that would mean in this situation that if you now call make migrations and if you call make migrations, this model would be ignored by Django. So if that leads to issues, that's your fault. You have to handle that. So if you change anything in actor, you also have to change it in the database model in two different places. Not a good thing to do, but if you want to do that for whatever reason, that's what you could do. So this meta class is super useful for many things, in particular when it goes into details of the database management system. So for instance, you can define constraints, we talked about. So constraints that have to be respected by transactions as well. You can define indexes, index structures like B trees and hash tables and stuff to speed up computation. That can be done here. Unique together, we talked about. You can say, oh, there's a default ordering. So whenever someone queries the tuples, the objects in that model, it must be ordered. So basically, this would implicitly always add an order by to the underlying SQL statement based on that. Yeah?
Are these things as specified in the meta class then maintained by the database or by Django?
No, that's a declarative aspect. I'm declaring in the object-oriented schema. And also, I now understand your question. And once you write it there, they will be considered as part of make migrations. Yeah, so now if you call make migration, let's assume you define an index, you call make migrations, then it will create that index. Yeah? So it's the same as for the actual schema definition. All of these things will be factored in when calling make migrations. Yeah? So you don't have to worry about that. Yeah? Otherwise, you would have two places again to edit the stuff. Yeah? Yeah?
So if I make something like unique together, then the database will make sure that...
Yes, so the database has in its create table syntax, in its data definition language, actually DDL, has statements for adding constraints to tables. Yeah? And that, if you add it to your model here, something like that, it will be added to the database schema. So you don't have to worry about that. Yeah? And that's exactly the idea. You add it here in one place, and then, I don't care, Django will handle all of the details with the database system. In particular, also, if some database systems have a slightly different syntax that may happen, Django would do all the translation for you. You don't have to worry about that. That's just one language you write down here, ideally. Yeah. Yeah, you can also specify the database table name. So we do that in our projects often because it makes it more readable. You can do things like make a class abstract or make a model abstract for subclassing, of course. That's very useful. Yeah, here's an example where you add a constraint. So here's a list of constraints being added to the database table. And that's basically constraining that the values in the attribute gender may only be of a certain domain. Yeah? I defined that in the project and said, okay, there's a list of possible values. So whatever a user tries to save in an object of this model must be contained in that domain. Otherwise, the database system will say, no, I'm not going to save that because you're violating that constraint. Yeah? Okay. What's a really cool thing, that's also what we used in one of our projects, that's called Schema Bootstrapping. So when you do what you learned in this lecture, you don't start with Django. You start with entity relationship modeling. From the entity relationship modeling, you create a relational model. So now you have a relational model and you feel like, oh yeah, Django would actually be cool. I want to do a Django web application around my model. You don't want to rewrite all of that again. But then you can ask Django to create the object-oriented schema for you. You don't have to do anything. And that's pretty cool because you only call inspect_db and pipe the output into a file, the models.py. Here goes your object-oriented schema. Here you go. Yeah, so you already have it. So you don't have to rewrite the entire schema again if you already have a relational model. And so this is super useful if you to connect an existing database to Django. So what that allows you to do is you can do the good old relational modeling as learned here. You refine that, you talk with customers, you refine it even more, and eventually you're happy with the model, and then you say, hey, now I create my Django object-oriented model. You set all the models to managed, and from there you continue only in Django. Yeah, you don't change it in the database anymore, you only do it in Django through migrations and make migrations. Yeah. And that's something I would recommend to do in this context. Yeah, so what is the query language? So the query language is, let's phrase it nicely, interesting. it has some issues. One is it always starts with a model. Yeah? So it's okay for smaller things, but for the real heavy lifting, you still want to use SQL. And actually, what you can do is you could bypass the ORM layer by sending SQL down directly. However, I don't recommend that because, again, due to security problems. So let's look at what this language can do. I'll just give you some ideas how that looks like. So this is how a query looks like in Python, in this query sets language. So basically here, I'm just saying the result, movies group by year count, is defined by this one. And what is this? Here I'm starting with the name of the model. Then I have to say objects.filter. Filter is the equivalent of where clause. Then you have to specify inside brackets what is the attribute name. Can I zoom in a little bit? Okay, so that's the attribute name year. And then there's no direct operator greater equal. You have to use the syntax underscore underscore greater equal 1999. That's how they did that. Then I go back from an object-oriented representation to a more JSON-style representation within the query by saying values, give me the values of the year column, and then I annotate it by a count. Yeah, so basically this is doing the grouping. It's pretty weird, I know. Maybe we first look at the SQL query, what I'm trying to do here. What I'm trying to do is something like that. Yeah? So there's a standard group by query we looked at. So we have a single input table, we have a filter, yeah? So only the movies that appeared in 99 or afterwards. And then I say I group by the year attribute, and then for each group being computed, I output the year and the count, so the number of movies that appeared in that specific year. So that's the relational result being shown here. So for all of those results, there was only one movie per year because we have this very small sample of the actual IMDb database. For 2003, there were 3 movies. That's what I'm trying to compute here. Yeah? And here it's expressed, yeah, it's a little hard to read. Yeah, group by is expressed with this values expression and then this annotate, and then writing the aggregation function here. I mean, the order by is clear what that does. Order by year, that's clear. That's how it is. Yeah? So, I mean, I've looked at other object-oriented languages and I didn't find any better one so far. So, I mean, so we have an ongoing project where we are actually looking at that as part of a thesis, how to improve that language. Yeah? But that's how it is. Don't shoot the messenger. That's how they did it. So basically, the object-oriented result of the query set will look something like this. Yeah? You will get this key value, the dictionary style notation, where you always repeat the attribute name and their values. Yeah? And then you have one dictionary for each of the results, for each of the groups being computed. So that's an example here. Yeah, keep in mind that you can always inspect the SQL command being issued underneath by Django ORM. And that can be done by just calling this function. Yeah? So whatever query you specified, yeah, so here in this case that was this expression on top, you just say .query underscore underscore string underscore underscore, and then you get the actual SQL statement being returned. And maybe we look at that in the project a little bit. So what I did in the project to, yeah, that's a similar query in the project. So all of these views not only show this display you want to have, but also show the SQL queries that were used underneath, that were used by the ORM to compute the result. Yeah? Okay, typically you won't need that, yeah? But just to illustrate what's happening here. So this is a query being generated, actually the same as on the slides. That's a relational result being created, and the number of queries is actually 1 in this example. Yeah. And you can do that for the other views here as well. You will see, okay, for this result, okay, that's a little bit more going on, obviously. Here, so we're seeing, oh, there's 3 queries actually being created. So it's not 1. And yeah, when you look at that, you see, okay, first it gets all the movies, yeah, all the attributes relevant for the movies, and it orders that by rank in descending order. That is the relational result you get. Yeah. And then it has another query where it looks up the directors, and it does that through an in operator, where it adds all of the movie IDs it obtained in query 0. Yeah, so from the movie IDs it found here, yeah, starting with this one, yeah, that's now here, it looks up all the associated directors. So it's not that it combines all of what you want to have into one query, but it may trigger multiple queries. Yeah, so and from there on it proceeds and proceeds. And the reason for that is actually how these web pages are generated. And yeah, there's another performance problem hidden here we're looking at in a research project, but that's another story. Okay, so the basic idea is something like this. So maybe we could look at other queries just to give you a little bit more of a feeling on how these look like. Let me look here. Yeah, that's the one we looked at here. Movie statistics. Here's another group by. I know without the filter, but other than that, it's the same thing. So often you have very simple queries like that. You know, we just spy, okay, that is a name. So that's basically what's done in the search method here. So if I specify a query name, whatever, a movie name, Aliens, that's something that actually exists, yeah? Then it will call this function, yeah, and then basically trigger this query set, query in ORM, computes the result, and also takes a primary key from the movie here and retrieves all the corresponding actors that took part in that movie, and so forth and so forth. So often those expressions are very, very simple. So I don't have more complex expressions here. Okay, right. Yeah, what you can also do is, so the question is, how do you work with the ORM? So one is you install an extension for Django, and then you can play with the query sets in your Jupyter notebook. But you can also run the Django server. That's what I'm showing here in PyCharm. Yeah, so basically what you see here underneath is that I started the server here. Yeah, and then once I start the server, it will give me a URL that I can use to access that server. So once I click here, I get some output being generated from the server. So for our example project, it's important, if you want to look at the web pages, you go to URL HTML. Yeah? That's the URL. So whatever this local machine, colon, then the port, and then HTML, that will return the HTML stuff I'm showing you in this lecture. Yeah? But here, basically, what I'm trying to say is, so I started the server here in PyCharm, my IDE, and then here you will also see the requests that are being made to the server. Okay. So what's interesting when you work with Django, and you will be working with that in the assignment this week, is you don't have to restart the server each and every time for changes you are doing. Yeah? So one cool feature of Django is really it listens to the changes on the file system. So when I change any of the files and save the files, the Django server will be restarted automatically again. This is super, super useful for development because you don't always have, well, restart, like a standard program. And so basically, while running the program, it will be replaced by the most recent version of your program. And that's a super useful feature of development here. So then the question is, how do we use Django from the outside? So there we have to talk about routing and views. So basically, it is something like this. So we have to have the user, yeah, and the user sits on a web browser and clicks somewhere. So he has a mouse click on his or her UI. And then the UI will trigger eventually will call a function call on the UI application. However that is implemented, it's JavaScript, PHP, or whatever. So you click here, the mouse click will be translated to a function call, and then in the UI application, you will make a request to the Django server. That's, in this example, a so-called GET request, retrieving some data. That's a read-only request. And the read-only request typically comes with a URL. That is the URL of the server plus a suffix. The suffix will determine which kind of data is to be shown. And what we will be looking at now is how that actually works in Django. There are two files that are very important here. One is the urls.py and the other is the views.py. So this is Django, the Django backend, and once it receives that request, it has to determine which data to return. And maybe we go here from, and maybe I show that with the slides. And then once the result to the request was computed, the result is returned to the UI application. The UI application may then trigger some screen re-rendering, maybe show some new tuple, some new result, whatever, and then the user will see that data, the new data being displayed, or whatever action he or she triggered by that mouse click. So that's basically the round trip we will be looking at in the second part of today's lecture today. Okay? So Django is doing two things. One is routing and one is so-called views. So let's start with routing, if this thing works. So the idea of routing is to map the incoming URL to a view. So you're calling the server with a, maybe you can also show it here again. You show it in the actual requests coming in. So that's a request, yeah? Those are statics, maybe that's not so interesting. I crashed. Where's a request? Maybe I trigger one request. So if I reload this one, so basically what you see is there are certain GET requests being issued, and this is GET HTML. So it's a GET request, and there's a suffix basically appended to the URL of the server. And how does the server now determine which function to invoke depending on this request? And that's first done by routing. So routing, the idea is really that you have certain patterns that you define those patterns in a file urls.py, and those patterns determine which function to invoke. So for instance, in line 8, this means, this entry here with a search suffix means that any URL with a pattern hostname/search will be routed to the user specified view get movie search. So this function will be invoked for that pattern. Or similarly for lines 7, 10, and 11, so any suffix starting with that will invoke this function. Movie statistics 2 suffix will invoke the movie statistics 2 function. So that's the binding you're doing, the mapping from URL suffixes to functions. And you can also specify parameters, of course. You can say here detailed / and then there's a string, and the string could be the key that you then use to look up a specific movie, the details for a specific movie. That's done in line 7. And that's also something you will be seeing frequently. So when I trigger this in the front end, so that's basically what happens here. Now if I click on any of those IDs, let's say Clockwork Orange, and then you go back to the server, you see, here, this view on the details was triggered. HTML/details/ the primary key of that specific movie. Yeah, that's routing, and the routing comes in many flavors, and then there is views. And basically there are two types of views a Django server can return. So one is you use Django as a standard HTML server. So you return HTML pages, like in a normal web server. That is the first option, and that basically means that the server, the Django server serves the pages you're displaying in the browser, the final pages being shown. And you see that in our example, if you look at the suffix HTML, so it's basically here. So if you just use this, and that's important for you to work with the project, yeah. If you start, if you just enter the URL of the server, you will see this display, but the web pages are displayed if you enter HTML. That is how routing is configured in this project. Yeah, so everything starting with HTML returns you web pages. But now if I leave that away, I get a different representation, and that is what is delivered by the so-called REST API. And what does that do? Here the idea is that the Django server delivers JSON documents. It just delivers the data, and then the actual UI application will use that data to update the web application. That's a standard way of doing it these days. So it's usually no one does option 1 anymore. Yeah, that's very uncool, as people of my age would say. Yeah? So people nowadays, this is a nice way of doing it, using Django as a RESTful server. And in our project, you see that if you have a suffix with API or the empty suffix. So again, if I enter something here and say API, I get the same thing actually, or I don't enter a suffix at all, that is what you get. And basically what is returned in a call is, I have to go here, is something like this. Yeah? So that's basically a JSON document rendered by your browser. The server is returning JSON, and the web browser is recognizing, oh, I'm seeing some JSON, so I display it in this hierarchical view. So that's basically what the Django server returns at that point in time. Yeah? And then your web application can make use of the data and put it into your web application and so forth and so forth. Yeah. Okay. So what I highly recommend, now maybe we first look at the HTML view definition. So here's an example. Here's an example how you define an HTML view. Yeah. Here's the view function. They always have the request as a parameter. And then you have some query returning the data you want to display. And then you eventually you define some context. That is used to fill out a so-called HTML template. So HTML template is, let me show you here, is something like this. So it looks like HTML, but then there is special characters here allowing you to write like for loops, for instance. Yeah? So that's a for loop saying, okay, for each object M, in this movies variable, and movies is actually a list of movies objects being returned, you output this snippet, please. Yeah? And in this snippet, you again have this syntax with double squirrely brackets, where you say, okay, here I output the primary key of that movie. Here I output the name, the year, the rank, and stuff like that. So with that, basically, you're marrying an HTML page with the data being returned by the query set of Django. And that's called a template. Yeah, so like a template in a, I don't know, in a document editing software, for like a mass mailing, if you want to do mass mailings or serial letters or stuff like that. Yeah? So here this stuff is filled out by what's called the template engine. And that's a template to create, you have to specify it to, here we were, yeah, to do something like this. And this template basically is specified here, yeah, in the view. You say, okay, that's the template I'm going to use, and this is my data. Those are the two things that need to be married by the template engine. The template with like the spaces or the variables, and the variables have to be specified here. So whatever you define here is then as part of your context. Yeah, you can then refer to as part of your template. That's the idea. So in this, what we do in the project, here are some extras. So as I told you before, in the server, I also compute the SQL queries for convenience for you to understand what's going on. So we added some extra code where we don't stop just displaying the web page, but we also display the SQL queries being issued, and that is what happens here in these methods. So you can basically ignore this stuff. That's just for completeness being shown here. So we add something to the return value here. That's this render with queries, and that's basically done by re-executing the underlying SQL query, to make sure that the web page No, I'm so sorry, I have to switch again. So that's the code on the slide. Yeah? So basically here, those are the methods I mentioned. You can safely ignore them. Yeah? So basically, what did I want to show? Yeah, the method you will be seeing very often in those view definitions is this method, render. Yeah? So render is again taking those 3 parameters. That is calling the template engine of Django. Yeah? And so for this request and for the given template, given this context, in other words, the data, please return the married page where the data was filled in. That's basically the only method you need. We just have these convenience functions here to display a SQL. Yeah, we looked at. That's an example for a template, and you see these kind of things in our project as well. When you look at templates, there's a templates folder, and then you have different kinds of things. For instance, for the statistics, there's a separate template folder. You see these kind of loops that are here for each object. Do stuff, output the year, and output the total. That was this group by aggregation query. And here we have an extra field where we output the SQL queries being used. So we pass those SQL queries as part of the context. And that's basically the things you do if you want to use Django as a web server. Okay. Yeah, if you want to use it as a RESTful server, and that's a standard way of what's being done today, there's an extension to Django you should install, and that's called the Django Rest framework, and that's really super helpful because it does most of the things automatically. So the idea, and here's an example for that. This old laptop here. Tablet. Okay, so what you do is assume you have a model movie, yes, and that's what we had before. So all you have to do is you specify what's called a movie serializer. So a serializer will serialize the data from that object representation into JSON, back and forth. Yeah? So you have to specify which are the attributes you're interested in for this specific model. And here I'm saying I'm interested in all of those 4 models. Yeah? Then what you define is called the movie view set that defines the behavior of a view, so a view returning JSON. And I'm saying here, okay, I want to really return all of the movies that are available. You could also introduce filters if you wanted, or do group by, or whatever query you deem useful. And then you say, okay, please use this serializer for this view. And then all you have to do in your URLs is to map to those views. For that, you create a router, give it a prefix, and so that's basically a suffix now being appended to the server address. And then you say that's a movie that's, or here the movie set, a view set that's responsible for rendering any results. Now, basically now if you go to your server, again, to go, boom. So what you see is here, it's not JSON, obviously. This is another feature of the Django Rest framework. It gives you a very readable view of the JSON document being returned. Yeah, so that's a little bit formatted, syntax highlighting and stuff. But if you call the server from your web application, you would receive JSON. So basically, you just look here, click to JSON, and that's basically what you would get. Again, formatted by the browser. Yeah. So what I said in the routing definition here was basically just this, saying, okay, now with the suffix movies, you get this JSON representation. And that's all you have to do. And that's super cool for REST because it allows you to super quickly define those REST views, which are also called endpoints in web development language. And that makes your life really easy. In particular also, you don't only get these get views, but what you also get is views that allow you to update stuff. Yeah, so if you go down here, you see there's also a form field allowing you to add movies to the server. Yes, or whatever. It's a big data engineering movie. Here, rank, I don't know. Give it a 10. Let's be. Is that fantasy? Mystery? I hope it's not horror. Romance? No, definitely not. let's say it's action. And then I do a post. So basically this data is sent to that endpoint already in the server. And we see it here when we go again to our server view. Oh, here's a post request. Yes, post means that's the write request. I will get to that in a moment, how that works in detail. But now I actually send a new tuple to the REST API, to this endpoint. That REST API automatically translated it to the ORM model, which automatically saved it in the database. Now, if you reread that page, I know it's in. I have to go back here. Let's go back. Oh, here it's already inserted it twice. Because no, I did reload on the post request. You shouldn't do that. It's inserted twice, yeah, and you have this already appearing in the database, yeah. And this is super useful for web development because you don't have to do nothing on the web server. Okay. Yeah, so that's how you use these REST endpoints, and I showed you the example for that. Yeah, again, so that's what I mentioned before. So when sending an HTTP request to a Django server, there are different classes of requests. Let's phrase it like that. And how that works is explained here in more detail. But all you ever have to understand is basically get versus post. The get means that's a read request. Post means that's a write request. Yeah? Can directly translate it to the database. And for get, you want to browse some data, want to read some data. For post, you want to change something in the database. And you should really keep these two apart. So basically, a get request is something like this, where you append like attribute value pairs to your URL. Yeah, you can do that through slashes or question mark and stuff like that. And then the server will analyze the URL and translate that back to internal representations of these attribute value pairs. In a post request, you don't do that. So the data you send is put in a body, and the body is sent in a way that's invisible to the outside. So you're not fiddling around with the URL. You always, when we see it here again, if we go to the server. Yeah. So we had that example here when we had the get request for here. Yeah? So here's a parameter being specified as a primary key of that movie. That's a get request, but you don't see that the post request contains the data I just entered. That's hidden in the body, and that's for security reasons. And you can specify those parameters, the body, so the content, so to say, of the post request you can specify freely in an application. Yeah, and that's all you need to know to develop such a web application. Yeah, that's what I wanted to say about Django. So I really recommend you to look at it. It's really cool. I just started developing myself last year with Django. I'm really surprised how cool it is and how helpful it is. And the nice thing is you can get productive very quickly. You see things, you can build things, you can try out things, and yeah, I really like that project. Yeah. I'm not saying there are also other projects that you can use to develop RESTful servers, but I mean, this is in Python, and it has a large user community, a lot of support, extensions, blah, blah, blah. So it's really a cool framework. Yeah. Any questions about Django? No? Okay, so again, the sample project is online on our GitHub page. Yeah? So with that, let's do a brief trip to security. So security in a web application. The problem with security and how it was typically done in the past days was, it was like an afterthought. People developed some stuff, and then afterwards, hopefully they thought about, oh yeah, we need some security, we need to think about that. And then they built it in afterwards. And that's the wrong way of doing it. But it's very hard to get it right after the fact. So the good way of doing it is from the start of the project, think about security. Yeah? Think about the things that can go wrong. And that's what I'm trying to express here in the beginning. Yeah? From the beginning, not just as an afterthought. So Django actually ships with a couple of security features. So the first thing you will run into and feel like you want to have it is user roles. You want to have a web page where you log in, where a professor has different possibilities than a student, stuff like that. Or someone who is part of the IMDb organization can enter movies. Someone who is not part can just view movies. these kind of things. So access control, user permissions, and that's, you get all of that for free. That's all available in Django. That's pretty cool. You know? You get SQL injection prevention. As long as you don't use, as long as you don't send raw SQL statements, you can also do that in Django. Don't do it. But if you only use query sets, you won't have a SQL injection problem. It's impossible. And that's cool because it's so easy to get this wrong. I've seen so many people getting this wrong. There's a couple of other things that are solved automatically. One is cross-site request forgery and many, many other things. So there's a long list of stuff Django provides you for free. However, and that's the bad news, that's not enough to run a web application. Yeah? And that's the problem you are in when fiddling with user data. Given the GDPR, the European Data Protection Regulations, you really have to be careful. It's not about only losing the data and the bad press you would have. It also can be really, really expensive if you lose user data or get hacked. And therefore, my recommendation is really get a security expert on board early from the beginning. And I mean this really. It's not optional, it's a must-have. And maybe you get 2 or 3, I don't know, depends on the size of the project, but it's really important because you have to have an expert on that, and database people are typically not the security experts on that. Yeah, and the SQL injection idea I mentioned, how does that work? So here's the idea, and that's really this loophole, this security exploit exists in many, many systems, unfortunately. Don't try it out with any existing real database system because you may get in trouble. So the idea is this. So at the end of the day, you have an application. You have a form where people enter stuff, enter a name, enter a profession, whatever. A string is being entered. And well, if you do a search-style query, that string will be appended to a SQL query at the end of the day. So for instance, if you specify a username as part of your application, at the end of the day, you will be appending it to something like this, to your SQL statement that will then select the users matching that name in your user database, for instance. So basically, you're concatenating strings here. So the username, Dietrich, or whatever, and then you retrieve all the users that are named where the name equals Dietrich. That's one thing you could do. Now the problem occurs because you concatenate. You just append the string specified by the user blindly to this SQL template, so to say. I mean, this whole thing is a template. And that is the reason why in computer science, whenever there's a template mechanism, you may do some sort of injection attacks. So in security, there are other injection attacks, not only SQL, that all have the same problem. Someone is trying to concatenate strings. Oh yeah, we're in trouble. So what you can do is, what if the username is something like this? Make sure you get the quotes right. So these quotes here just are from your programming language, the Python quotes, and everything here, that's the single quotes, are part of that string. Now, if I put this stuff here and concatenate it blindly, I will create the following string. Select star from users where name equals the empty string or 1 equals 1. 1 equals 1 is true, right? So it's always true. Whatever you do, this will return the entire database, the entire table users in this example. And that is what's called SQL injection. So originally, the idea of the developer was to retrieve just this one user being specified, but here it's actually the entire database. And this hack is used to steal entire databases, not only single relations. And here's a more visual example of what's going on here. So that's the same example as from the slides. So I have this string, I enter it here, I end up with this wild expression, and basically the colors here mean that is a string. And now the problem occurs because you leave the interpretation up to the database system. You just pass a string to the database system, and then you tell the database system, here I assembled a string, the SQL string, and you do something with that. You find out what is a SQL command and what is the actual parameter, the constant. That is what these other colors mean. So green means that's the SQL command, And orange means that's the parameter. Yeah, so green is SQL stuff, orange is parameter. And that is not what the developer had in mind when writing something like that, obviously. Yeah, that's not what was intended when writing that down. So how do you fix that? The right way of fixing that is, I mean, of course, you could always try to inspect, for instance, the inputs, yeah, and say, oh, is there some or, is there some single quotation, is there some X, is there some Y? You could do that, but actually you shouldn't, because you might be missing a case for SQL injection. So the right way of doing it is something like this. You specify it as a parameter, and then you send this stuff, the actual template, together with the parameters in two separate fields of the call. So here you're seeing here I have an execute method where there's a query template being specified, that is this one, and then its parameters. And that means that with this call, you already make clear, hey, whatever happens in the following, this stuff here is a part of the query, and this stuff here is part of the parameters. That means the interpretation of the database system will be the following. It will say, okay, well, that's a wild constant, but who cares? That is what was passed. That is the stuff that was passed to me. So basically, it will, the query will be unchanged, and this query will return all users where the name is equal to single quote space or blah, 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 if someone is named like that. Yeah. But it will not change the semantics of the query. It will only return at most one user. If there's a user with that wild name, it will return that. If not, it won't return anything. And that's the way to avoid SQL injection. Again, if you are handling, so that's very important for you if you not natively work with SQL. If your application sends SQL commands, it's absolutely paramount that you search for a command like this, where you pass the template and the parameters separately. All database drivers have something like this these days. But never concatenate user-specified variables into a SQL string. That's the road to hell. Don't do this. Okay, here's another example. Yeah, because it's not only useful for reading, but you can also use that for dropping an entire database. Yeah? So, yeah, I mean, you have to have some creativity to do that, and in particular, the quotes are the problem. Yeah? Because if the quotes were written like this in the original statement, okay, then you have something like you write blah, whatever, quote closing, drop table users, that deletes the table users. Select star from blah, that you just enter this stuff because you have to fix a problem with a single quote. Yeah? This creates this string, yeah, which will drop all of the users table just by entering the right parameter. Yeah? You can not only steal data, you can also bring down the database. And let's hope there's a backup for that table, but that's something you can do. Yeah? Of course, assuming that the user who's issuing that has the access rights to drop a table. Yeah? That could also be forbidden, but if you forgot to forbid dropping table or deleting data, then you will be dropping the table. And that's why there's a running gag in database systems. That's this one. Maybe you read that. So this is a SQL command. So there are multiple ways of running SQL injection attacks. That's another way of doing it. But it's like and so if you ever become a parent, or you already are, maybe consider naming your son like that and giving it a try with a Saarbrücken city, whether that works. Of course you don't. Yeah, little Bobby tables. So as mentioned before, what you could do is you could also sanitize your database inputs. The confusion here is what belongs to the SQL query and what is parameter of the query. However, as mentioned before, unless you're extremely competent with your query language and have a security background, never write your own sanitizer. So don't just do it by inspecting the user-specified parameter and then concatenating it anyway. Don't do this. Yeah? Just use a function that splits up the template and the parameters and two different variables, two different parameters to the call. Anyway, most database libraries and ORMs have some features to do sanitization for you through prepared statements or bind parameters. Yeah, of course we have a notebook on that. Let me open that up. Here's a notebook, but that's basically explaining what we had on the slides. Okay, currently start clean output. So here's the users table. I'm using DuckDB again and create a table users similar to what we had before. There's also a password field. So, and here I do what I just showed on the slide. So now I say, okay, the username that could come from a web front end is now this wild string. That would create this string. And now if I pass that to that function returning that username, it would return the entire table. That's not the idea. It should only return one of those entries like here where I specify Marcel and I get this entry with Marcel. Now here I get the entire table being returned. That's what we saw on the slides. And we can do the same thing here with this drop table statement I showed on the slide. So I would construct this query. Yeah, I call the function. And now if I do a select star from the same relation again, I get, oh, no, this table name users doesn't exist. So it was really deleted. And one way you could do is to split that up, as told before. Actually, database has some more options of doing that, and one is called prepared statements. But basically, what you're seeing here is such a call that splits up the template, yeah, with a parameter here expressed by question mark and the actual constants. That's what we're seeing here. Yeah. So we have to reinitialize the database because we killed the table. So now if I query for Lucas, I get this one. And if I query for this user, I only get that user. Yeah, because we actually inserted a user with this username. That's why some result is being returned. That's exactly the string the database is looking for. It's not concatenating if I use this call with that split in template and parameters. And that's why I get there is a user. If there weren't such a user, I wouldn't return anything here. It wouldn't find anything. And if I do something like this with drop, it doesn't return anything. I can still execute my queries. Nothing has happened. Yeah. So that is really important. It's easy to get that wrong. So make sure whenever you call SQL, you have a method like that. That's really important in code reviews. Okay. Yeah, here's some further material. So I invite you to look at the Django documentation. But maybe if you are new to Django, I would start with something of those. So the Django documentation is sometimes a bit hard to read, so rather go to the 3 schools. The Django tutorial is pretty good, or Real Python is always pretty good at explaining stuff for additional material. Yeah, so bottom line, maybe if you go back a little bit, we have that time. And look at that layered architecture. Here we are, right. Yeah, so that's basically how we started today. And now we peeped a little bit into the ORM, this translation layer, and a little bit in this backend framework, allowing you to get data out of the database. So I really invite you to play with that. It's a lot of fun, and it's really useful for developing web applications. So much from my side. That's call it a day. See you next week. Thanks.